Good morning, students. I am Tejaswini from TTWREIS Girls Churchalla. Today I would like to discuss about an interesting topic. Before going to start this topic, I would like to ask some questions to students. Are you ready? In our daily life, we use a lot of materials. Even our food has a lot of variety. From my question is, what kind of food do we eat? Generally, we eat fruits, vegetables, pizzas, burgers, etc. So, are all the items have same taste and color? No, different items have different taste and different colors. Some of them sour in taste, some of them sweet in taste, some of them bitter in taste, and some of them sweet in taste, isn't it? So, look at this slide, children. What do you observe? Here we have lemon, grapes, baking soda and soap. A boy is bathing now. So, my question is, what is the taste of lemon and grapes? So, you are absolutely right. So, they are sour in taste. And when we rub the soap solution between in your hands, you feel, what do you feel? Yes, you feel soapy or slippery. So, the substances which are sour in taste, they are called acids, and the substances which are bitter in taste and soapy to touch, they are called bases. So, in this session, I would like to discuss about acids and bases. So, our topic name is acids and bases. So, the word acid is derived from a Latin word acidus. Acidus means sour. So, the another definition of acids is, so the substances which dissolves in water and gives H plus ions, they are called acids. And the bases, so the substances which can dissolve in water and gives OH minus ions in water, they are called bases. So, look at the another slide, children. Here we have the substances that we are used in our daily life contains different acids and different bases. Here we have lemon, tomatoes, grapes and apples and vinegar. So, here lemon contains citric acid, tomatoes contains oxalic acid, grapes and tamarind contains tartaric acid. So, milk and curd contains lactic acid and buttermilk also. So, apples contains malic acid, vinegar contains acetic acid. So, ant releases formic acid. So, we feel a burning sensation when bitten by an ant. So, because this is the presence of formic acid by ant releases. So, on the other side we have household bases, that is baking soda, soap, ammonia, drain cleaners, shampoo and glass cleaners. So, soap contains potassium hydroxide, glass cleaners contains ammonium hydroxide and shampoo contains sodium hydroxide. So, these are the household bases. Among from these natural acids, we have hydrochloric acid. Hydrochloric acid formula is HCl, and nitric acid HNO3 and sulfuric acid. So, these are the acids which we are preparing from minerals. So, these are called mineral acids. So, these are the strong acids than natural acids. So, the strong acids means, so the acids which undergoes 100% ionization, they are called strong acids. So, for example of strong acids, HCl, that is hydrochloric acid, nitric acid HNO3 and sulfuric acid H2SO4. So, and the acids which is less than undergoes 100% ionization, that is which is less than 100% ionization is called weak bases, that is weak acids, that is acetic acid and formic acid and carbonic acid. So these are the weak acids and as well as bases. So the bases which undergoes 100% ionization, they are called strong bases. For example of strong bases, sodium hydroxide, the formula of sodium hydroxide is NaOH, and potassium hydroxide and lithium hydroxide also. So the bases which undergoes is less than 100% ionization is called weak bases. That is, the examples of weak bases are magnesium hydroxide, MgOH taken twice, and ammonium hydroxide is also. So these are the strong acids, weak acids, and strong bases, weak bases. So we cannot taste every substance. If we taste, it is harmful to us. Then how do we find the nature of substance? With the help of indicators. So indicators are the substances that change color when we added the solution contains acid or base substance. So indicators, basically indicators of 4 types. So next, indicators. So first one is natural indicators. And second one, synthetic indicators. And third one, olfactory indicators. And last one, universal indicators. So natural indicators, these indicators are occurring from nature. So turmeric, litmus, petals of hibiscus and beetroot are the examples of natural indicators. So the examples of natural indicators is litmus, turmeric and petals of hibiscus or extra, etc. Then synthetic indicators. So methyl orange and phenolphthalein. And methyl red. So these are the synthetic indicators. And next, olfactory indicators. So olfactory indicators can change their smell when we added acidic and basic substances. In acidic substances, they do not change their smell. In basic substances, they lose their smell. So basically, vanilla essence and onion juice are used as olfactory indicators. And next, universal indicators. So universal indicators is the combination of or mixture of all indicators. Generally pH papers are used as universal indicators. So the pH value is less than 7, they are acidic in nature. Then pH value is greater than 7, they are basic in nature. So these are the indicators. So in this session we have discussed natural indicators and synthetic indicators. So the first natural indicator is turmeric. So here we have turmeric paper. it is very easy to prepare this. You can also prepare this. So take some turmeric powder and add a little bit of water to make a thick paste and rub the paste on a white sheet and dry it. Here we have turmeric paper. So here we are doing one activity with the turmeric paper. And what happens when the turmeric paper is dipped in different solutions? In this activity we have lemon juice and soap water. So here I dip the turmeric paper in lemon juice. What happened? So the turmeric did not change any color. Before dipping, the turmeric is yellow in color, and after dipping, the turmeric paper doesn't change any color, it is yellow in color. I dip the turmeric paper in soap water. What do you observe? So the turmeric turns red color. So in our daily life, you might have observed when a turmeric stain on your white cloth becomes red when we wash with soap water, because the soap contains sodium hydroxide is a base. So when we add it with turmeric, it is red color. And next natural indicator is litmus. So litmus can extracted from lichens plant. So litmus is generally in the form of solution or in the form of strips. Here we have litmus strips. Here we have two types of strips, that is red litmus and blue litmus. So here blue litmus papers and red litmus papers. So this is red litmus and this is blue litmus. So here we are doing one activity. In this activity we have 3 bowls. So one bowl contained with lemon juice and one bowl contained with soap water and another bowl contained with salt water. So here I dip the blue litmus paper and red litmus paper in each solution one by one. Let's see what happened. So in lemon juice, the blue litmus turns which color? Red color. So in acidic substances, the blue litmus turns red color. After I dip the red litmus in same solution, that is lemon juice, what happened? So that red litmus did not change any color, it remains same. And I dip the red litmus and blue litmus in soap water. What happened? So the blue litmus did not change any color. This is blue color. So after that I dip the red litmus in soap water. So here the red litmus turns blue color. So instead of soap water, if you use lime water, so the red litmus is also turns blue. And I use the blue litmus and red litmus in salt water. Let's see what happened. What happened? The blue litmus did not change any color. And I again dip the red litmus in salt water. What happened? So the red litmus did not change any color. Look at the another slide, children. So the substances that turns blue litmus to red are acidic in nature. So for example of acids, HCl, HNO3 and H2SO4, that is hydrochloric acid, nitric acid and sulfuric acid. So the substances that are soapy to touch and turns red litmus to blue are basic in nature. For example, sodium hydroxide, potassium hydroxide and magnesium hydroxide. So the substances did not change the color of either blue or red litmus. So they are neutral in nature. For example, salt water. So here, the next slide. In this slide, we have some natural indicators. So litmus solution, turmeric solution, we already discussed that. So beetroot juice are basically purple in nature. So in acidic substances, they give purple color, and in basic substances, they give yellow color. So red cabbage juice, basically purple in nature. So in acidic substances, they give pink color. In basic substances, they give green or yellow color. So China rose solutions are hibiscus solutions. So these are red in nature. In acidic substances, they give magenta color. In basic substances, they give green color. So these are the natural indicators. And the another type of indicators is synthetic indicators. So the examples of synthetic indicators is methyl orange, phenolphthalein and methyl red. So here we have methyl orange indicator and phenolphthalein indicator. So methyl orange is basically orange in color. So phenolphthalein is a colorless solution. So here we are doing one more activity. In this activity, we have 2 bowls of lemon juice and another 2 bowls of soap water. So here I am adding the methyl orange indicator for a few drops in lemon juice and soap water. Let's see what happened, what color changes to be occurred in these substances. I drop few more drops. So the lemon juice turns red color and the soap water turns yellow color. So the methyl orange indicator gives red color in acidic substances and yellow color in basic substances. Again I am adding phenolphthalein indicator in lemon juice and soap water. So phenolphthalein remains colorless in lemon juice and in soap water it gives pink color. So in our villages we might, if you observe, so a magician or a juggler when cuts with lemon with a knife, so a blood comes out of it. Do you believe that is it blood? No, it is not blood. Actually, he uses the knife with dipped in methyl orange indicator to cut the lemon. So when methyl orange is mixed with lemon, it gives red color. So the blood, so the lemon juice appears as blood, but it is not blood. If you see this type of magics, you don't believe that, because you can also do this type of magics in your home. So next chemical indicators, that is we already discussed that methyl orange gives red color with acids and yellow color with bases. So phenolphthalein remains colorless in acidic solution, while it turns pink in basic solutions. So these are the some properties of acids and bases. And next, so we will discuss the chemical properties of acids and bases. So look at this slide, children. So when acids are react with bases, it gives salt and water. So when acids, HCl is a acid. So when acid react with bases, so NaOH is sodium hydroxide is a base, it gives salt. So when base is mixed with acid, we can get salt and water. So first chemical reaction. And next, when acids are react with metals, it gives hydrogen gas and its corresponding salt. So when acids are react with, hydrochloric acid is react with metal, zinc is a metal. So when zinc is react with hydrochloric acid, zinc chloride and hydrogen gas is formed. So when a burning matchstick near the test tube, so the burning matchstick catches fire with a pop sound. So it is the identification test of hydrogen gas. So when acids are react with metal carbonates, that is sodium carbonate, it gives carbon dioxide gas and water and its corresponding salt. So carbon dioxide is a gas. So when burning matchstick is we keep the burning matchstick near the test tube. So the burning matchstick will, the fire will extinguish, means stops burning. So pass the gas into lime water. So the lime water turns milky white. So this is the identification test of carbon dioxide gas. So acids are basically corrosive in nature. So due to this corrosive property, the pickles, jams, jellies are not stored in metal containers. So they are stored in plastic containers. So acids are good conductors of electricity. So these are the chemical properties of acids. And next, bases. So when bases are react with acids, it can also give salt and water. So this type of reactions are called neutralization reactions. So next we will discuss uses of acids and bases. In our daily life, we have a lot of benefits with with acids and bases. So our stomach secretes hydrochloric acid. So in digestive gland secretes hydrochloric acid per day 1.2 to 1.4 liters of HCl. So this HCl helps us to digest our food. And carbonic acid is used to make cool drinks, and citric acid is used to make orange juice and making pulihora. So acetic acid is used to make storage food. And sulfuric acid. So sulfuric acid is the most widely made industrial chemical in the world, used to make paper, paint, detergent and fertilizers. So these are the some uses of acids. And next, bases. So sodium hydroxide is used to make soap, paper, oven, drain cleaners and products to unclog drains. So calcium hydroxide is another name of lime water. So calcium hydroxide is used to make plaster of Paris, gypsum or cement. So ammonia is found in household cleaners and to make fertilizers. So magnesium hydroxide and aluminum hydroxide are used to antacid to treat heartburn. So these are the some uses of acids and bases. And next, neutralization reaction. So the reaction between an acid and a base, it produces a salt and water. Here when acid react with bases, they give salt and water. This type of reactions are called neutralization reactions. So in neutralization reactions, salts can be formed. So salts either acid or base or neutral. So in our daily life, so neutralization reaction is also useful to in our daily life. So here in this slide, we are discussing applications of neutralization reaction. So when bee stings are acidic and can be neutralized with baking soda. So when wasp stings are alkaline and it can be neutralized with vinegar. So our stomach carries hydrochloric acid. So if excess of hydrochloric acid is secretes, we feel indigestion. Too much of this leads to indigestion. To cure this indigestion, we can neutralize the excess acid with baking soda or specialized indigestion tablets. So in this session, we are discussing acids and bases and the properties of acids and bases and indicators. So the types of indicators and uses of acids and bases, neutralization reaction, and the applications of neutralization reaction. So thank you for this opportunity. Please stay home and stay safe. Thank you.